how about we graph sine and cosine? And let's start by filling in this chart. And this is going to look a little mundane at first. But these numbers are going to come from the unit circle. And we're going to be graphing sine of x, where x is 0 degrees, 30 degrees, 45. We're going to go all the way around through a full circle. And when we do, we'll see what happens. So here goes. Sine of 0 degrees, that's the y value, that would be 0. So we're going to put a 0. Let's put it right here in blue. Sine of 30 degrees, it's the y value, that's 1/2, and then square root of 2 over 2, and then square root of 3 over 2, and then 1. And we're basically just going to keep going around the circle. That's what we're doing as we fill in this table. So I'm just going to set the unit circle aside and fill in the table from here. So 0, 1/2, square root of 2 over 2, square root of 3 over 2, 1, and then it goes back down in the same pattern. It went up and then 0. A lot of patterns in there. This is like square root of 0 over 2, square root of 1 over 2, square root of 1 is 1, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Just saying, square root of 4 is 2, 2 over 2 is 1. There's your pattern. Anyway, and then we'll do these down here. And -1, and then back to where we were, and then 0. Okay, the whole chart has been filled in. What I'm going to do is convert these to decimals just to make it a little more practical, and then we're going to plot this and connect it. I'm going to use a pencil to do that just so I don't make any mistakes that I can't undo. So let's turn all these into decimals, except the 1/2. Obviously, 1/2 is 0.5, so no need to do that. Square root of 2 over 2 is 0.707, so I'm going to do that for all my square roots of 2 over 2, even the negative ones. So negative 0.707 for those, and negative 0.707 for those. Don't let this process take too long. Square root of 3 divided by 2 is 0.866. So 0.866 for all of these. 0.866 negative 0.866. 0.866. Okay, so what I want to do is make a plot of this basically, and I'm going to use a red pen for this, but then connect them with a pencil. So 0, 0 is a coordinate, and I'm just getting the coordinates from here. 30 degrees, comma 1/2, and 30 degrees is here, and then 1/2 is there. And then 45 degrees is here, and then I want to go up to 0.707, which is just a little less than 3/4. So well, let's see, that's 0.6, that's 0.7, that's 0.8. So we're about right here. And then 60 degrees is 0.866, so it's, let's see, about right here-ish. And then 90 degrees is at 1. So if you want to go ahead and connect those, you can. And you're going to see a slight curve that happens like this. Okay, so then it comes back down, and I can read off the chart, or I could just notice some symmetry that's happening here around 90 degrees. And so 0.866 is going to happen there at 120. 0.707 is going to happen there. And then we're going to have this one here, and then we're back to 0. And so connecting those brings us, whoops, missed that point, back around to there. All right, now we dabble into the negatives, so let's go. At 210 degrees, almost said the wrong number, 210 degrees, which is right here, we're going to go down to negative 1/2, which is there. And then negative 0.707 at 225, which is along this vertical line here. And that would be just a little bit more right there. And then 0.866 at 240, and then -1. And then we have the symmetry. I'm going to go ahead and bring this one back up. It's kind of a meticulous process. But then at 360 degrees, we're back to 0. And I hope you notice what is happening. Okay, some stuff that needs to be pointed out here. This is what we call a sinusoidal graph. Sinusoidal is a mouthful, but it's because it's the graph of sine. I guess cosine might be cosinusoidal. I don't know, never looked it up. Feel free to Google that. So this is going to go up and then down and then back where it started, but we have had a conversation about coterminal angles. So let's think about this. If I wanted a 0-degree angle, I'd be here, the same as 360. If I wanted a 720-degree angle, I'd go around twice. If I wanted a 90-degree angle, I'd go here, but if I wanted another 360 degrees on top of that, I'd be back here. So here's what's really happening. This graph is going to repeat. So it goes up and down and back, and it can go over and over and over again. So you could extend it, and it's going to continue its journey, and it's going to keep going, and it could go back into the negatives as well, depending on the context of the problem and the domain associated with it. But this is a sinusoidal graph that is going to repeat. A little bit of vocabulary that you're going to encounter in the next video has to do with amplitude. So let's go ahead and write just a few things down. In this particular problem, the amplitude is 1. All right, amplitude is the distance from the middle to the top, or the middle to the bottom. The highest this gets is 1, the lowest it gets is -1. So the amplitude is the distance from the middle to the top or the middle to the bottom. I say middle, I'm probably going to use the word midline a lot because that's the context for it very frequently. Another word that we're going to use is period, which means the length of time it takes to make one entire cycle. And we go from here up, down, and back up to where we started in 360 degrees. So the period is 360 degrees. We could also talk about this in terms of radians, which will happen later, and we could say that's 2 pi. So 360 degrees or 2 pi is going to be one full period, one full cycle of going up, down. Now I know we're back where we started, but then we have to go all the way down and then back up. There's one period. And then we're going to have the vertical shift. Vertical shift, which we often call the midline. And the vertical shift in this case was none at all. It's centered at 0. I could draw a line through 0, and I would have just as much graph above as I do below. So this is going to be 0. So again, amplitude is the distance from the vertical shift, the midline to the top, vertical shift to the bottom. Period is how long it takes to make one full cycle. Vertical shift is basically where the middle of this thing is.